A stone cairn stands about 200 yards below a heated building at the top of a mountain in New Hampshire. A 23-year-old woman froze to death beside it, close enough to reach the door in minutes if she could have seen it. This is Mount Washington, the highest peak in the Northeast, and more than 150 people have died here since 1849. You can drive to the summit. 3 storm tracks collide over this range, and the terrain squeezes the wind until it screams. But wind is not what kills you here. Distance is. Why? Hold on to that question, because it is going to fight you the entire way up this mountain. It sounds wrong. It sounds like the kind of thing you say to be clever. 6,288 feet is not a serious altitude by the standards of the world's great peaks. There are hills in the American West that are taller than this, and nobody remembers their names. There is a paved toll road that climbs to the top of Mount Washington, and in the summer, a family in a sedan can reach the summit in about 30 minutes. Buy a sticker that says they made it, and drive back down before lunch. There is a cog railway on the other side that has been carrying tourists up the western slope since 1869, chuffing along at a walking pace behind a small steam engine. There is a snack bar at the top. There are bathrooms. On a clear July afternoon, it is one of the most accessible mountaintops on the planet, and thousands of people stand on it every year without a scratch, take a photograph, and go home. And that is exactly the problem. That is the trap. And it is worth being blunt about it right at the start, because the accessibility is not separate from the danger. The accessibility is part of the danger. A mountain that is hard to reach is a mountain that filters its visitors. It only lets serious, prepared, committed people onto its upper slopes, because getting there is work, and the work weeds out the unready. Mount Washington does not filter anybody. It invites everybody. It puts a road and a railway and a snack bar at the summit, and it says, come on up, it's easy. And most of the time, it is telling the truth. The lie is in the word most, because the same summit that a car reaches in 30 minutes in July has recorded a wind speed of 231 miles per hour. The same summit with the bathrooms and the gift shop has held a temperature with the wind factored in, that would freeze exposed skin in under a minute. The mountain does not warn you that it has 2 personalities. You have to already know. And most people never learn the difference because most people only ever meet the first face. That is the quiet arithmetic hiding behind the death toll. Thousands come and go every year without a scratch, and their easy afternoons become the story everyone tells, the reputation the mountain hides behind. Then, on the days that never make the brochure, the second face appears, and it does not appear to the thousands. It appears to the one party that happened to be on the upper cone at the wrong hour, and by the time it appears, they are already committed, already too high, already too cold. The safe visits build the legend of an easy mountain, and the legend is the bait. And the bait is baited with a snack bar and a paved road. So here is the shape of what is coming, laid out plainly so you can watch it assemble, because the pattern matters more than any single death. In 1855, a tourist on a resort holiday died within a short walk of a hotel she could not see. In 1900, 2 of the fittest endurance athletes in the country died in the last week of June, one of them within a few hundred feet of the summit. In 1982, a trained rescuer was killed searching for 2 young climbers who came off the mountain alive but without their legs. And in 2015, an experienced mountaineer died carrying a satellite beacon that told the world exactly where she was, almost the instant she got into trouble. 4 people, 160 years between the first and the last. And in that span, everything changed. The clothing changed from wool and leather to synthetics engineered in laboratories. The forecasting changed from a barometer and a guess to satellites and supercomputers. The communication changed from a shout carried on the wind to a distress signal that reaches space in seconds. Every tool a human being uses to survive a mountain was reinvented from the ground up between the first of those deaths and the last, and all 4 of them died inside the same 2-mile circle of rock. For the same reason. Not 4 reasons. 1. Hold that number, 1, in the back of your mind the whole way up. Because the entire mystery of this mountain lives in the gap between how much changed and how little it mattered. To understand why this specific lump of rock in northern New England behaves the way it does, you have to stop thinking about how tall it is and start thinking about where it sits and how the air gets to it. Height is almost a distraction. What matters is that Mount Washington is the tallest thing in the presidential range. And the presidential range is the tallest thing in the northeastern United States. And it stands broadside to the way the weather moves across the continent. In the mid-latitudes of North America, the prevailing winds come out of the west. The great weather systems of the continent are born over the Pacific, march across the Rockies, spread out over the enormous flat interior of the country, and roll east. By the time that air reaches New Hampshire, it has crossed thousands of miles of plains and lakes and low country with almost nothing tall enough to slow it down or break it up. Meteorologists have a word for that unobstructed run of open ground that a wind crosses before it hits something. They call it fetch. The longer the fetch, the more organized, and the faster the air arrives, because friction with the ground is the main thing that steals a wind's energy, and there has been very little to rub against. The air that hits Mount Washington has had a running start that begins near the Continental Divide. There is a reason people who study weather talk about this one summit the way they talk about very few places on land, and it is not just the fetch. It is that 3 of the major storm tracks that organize weather across North America happen to converge over the Northeast, and Mount Washington sits close to where they meet. Storms that come down out of Canada from the northwest, the fast cold systems, sometimes called Alberta Clippers, run one road. Storms that form down toward the Gulf of Mexico and ride up through the interior of the continent run another. And the storms that spin up along the Atlantic seaboard, the nor'easters that bury the East Coast in wind and snow, track northeast, right past the region on a third. Any given system might arrive by any of those roads, and the truly bad days are the ones where more than one arrives at once, or where one hands its energy off to another right over New England. On top of that, the polar jet stream, the high-fast river of air that divides cold northern air from warmer southern air and that steers the storms themselves, frequently parks directly over northern New England. That matters because the summit at 6,000 feet reaches up far enough to feel that upper-level flow in a way that lower hills never do. So the mountain is not merely tall and not merely broadside to the westerlies. It stands at a continental crossroads, at an altitude that pokes into the steering currents, exactly where the traffic is heaviest. That is not marketing. That is a consequence of where the range decided to stand, and the range is not going to move. So the air arrives fast, and it arrives clean, and then it meets the wall. The presidential range runs across its path, and the range is oriented almost perpendicular to that westerly flow, which is close to the worst possible angle. The wind cannot go around a barrier that wide, so it has to go over. And here is where the mountain stops being a passive obstacle and becomes an engine. When you force a moving fluid, and air is a fluid, through a narrowing space, it speeds up. It has to. The same amount of air has to get through. And if the channel gets tighter, the only way the same volume can pass in the same time is to move faster. You feel this every time you put your thumb over the end of a garden hose and the water jumps into a hard, fast jet. That is called the Venturi effect. And on Mount Washington, the narrowing space is the gap between the summit and the base of the stratosphere, the ceiling of the weather. The range shoves the air up against that ceiling and pinches it, and the air accelerates through the gap the same way the water accelerates past your thumb. The summit sits right in the throat of that constriction. It is not a peak that happens to be windy. It is a peak that manufactures wind, standing in the one place where the manufacturing happens. And because the range forces so much air upward so often, the summit spends an astonishing amount of its time not under clear sky but buried inside the clouds themselves. When moist air is shoved up a slope, it cools, and cooling air cannot hold as much water, so the moisture condenses into cloud right there against the mountainside. On Mount Washington, this happens so routinely that the summit sits inside fog, on average, on the order of 300 days a year. Sit with that number and translate it into experience. For roughly 2 days out of every 3, the top of this mountain is inside a cloud. That means for 2 days out of every 3, there is no horizon up there. No distant landmark, no visible destination, nothing but the few feet of rock the wind will grudgingly let you see. The postcard summit, the one with the sharp blue view of 5 states and the distant sea, is the exception. The normal condition of this mountain is blindness, and that single fact reaches forward across every death in this story, because you cannot walk to a door you cannot see. And the fog up here is not the soft, harmless mist of a valley morning. In the cold months, the water droplets suspended in that cloud are supercooled, still liquid even though they are colder than freezing, held in that unstable state until they touch something solid. When they touch a railing, a sign, an instrument, or a person, they freeze on contact instantly and keep building layer upon layer into a hard white crust called rime ice. Rime grows into the wind, forming long feathery blades that all point the same way, back toward the wind that made them, so that on the summit, even the ice becomes a compass, showing which direction has been trying to kill you. It coats every exposed surface in inches of ice in a matter of hours. It jams instruments. It disguises the true shape of the ground so you cannot tell a step from a drop. And it turns a handrail into a smooth, freezing tube that a gloved hand cannot grip. So the same process that blinds you with fog is, at the very same moment, encasing everything you might grab or read or aim for in ice. Fog and rime are not 2 separate hazards you might get one or the other of. They are one process, condensation on a mountain that shoves air upward, and it runs for most of the year. Now add the reason the wind is not just fast, but relentless. Wind is driven by pressure difference. Air flows from high pressure to low pressure, and the harder the difference is packed across a short distance, the harder the air moves. Mount Washington sits in a part of the world where storm systems love to intensify, where cold Canadian air masses meet warmer, wetter air riding up the eastern seaboard, and where the jet stream frequently parks itself directly overhead. When a deep, low-pressure system stalls to the north or east of the mountain and a strong high builds in behind it to the west, you get an enormous pressure difference squeezed across the region, and the wind that results does not gust and fade. It settles into a sustained roar that can hold hurricane force for hours or days. And force does not rise politely in step with speed. It rises with the square of the speed. Double the wind, and you do not double the push. You quadruple it. A 40-mile-an-hour wind that you can lean into becomes at 80, a wall that knocks you flat and can pick a grown adult off their feet and throw them. This is why survivors of the mountain's worst days describe crawling, not walking bent over. Crawling on hands and knees, because standing up means being launched. Translate those numbers into your own body, because a wind speed on a screen means nothing until you feel what it does to you. At 30 miles an hour, you notice it. At 40, you can lean into it, and it holds your weight. At 60, the threshold where the observatory's own staff clip into fixed ropes before they step outside. A person of ordinary size can no longer count on staying upright, and loose gear starts leaving. A hat, a mitten, an unzipped pack, snatched off and gone downwind before you can grab it. At 80, the wind is a solid wall that knocks you flat and slides you across the ice on your back. Past 100, and this mountain tops 100 miles an hour on more than 100 days a year, staying on your feet is not a decision you get to make anymore. You crawl, or you are moved. And it is worse than those thresholds alone suggest because of that square law we just met, the one where doubling the speed quadruples the force. That is why a forecast can lie so effectively without printing a single false number. A prediction of gusts to 70 sounds like a slightly rougher version of gusts to 40, an unpleasant but manageable step up, when in truth it is several times the force, more than enough to take a person off their feet on open ice and end the day. The danger on this mountain does not rise along a gentle ramp you can feel yourself climbing and step off in time. It rises along a curve that accelerates away from you, so that conditions which felt merely bad an hour ago become conditions you physically cannot stand up in, and it arrives faster than human instinct expects. And there is no lull to wait it out. On gentler ground, a storm arrives in gusts, a blast, and then a pause you can move in. Here, once the gradient locks in, the wind does not pause. It becomes a single unbroken weight leaning on your body, hour after hour, and the only thing in the equation that ever tires is you. Here is the piece that turns all of that meteorology into a killing machine. And it is the piece most visitors never think about: trees. On most mountains in the world, the lower slopes are forested, and the forest is shelter. It blocks wind, it holds soil. It gives you something to hide behind and something to navigate by. On Mount Washington, the trees give up at around 4,400 feet. Above that line, the forest thins into a band of stunted, wind-tortured crumholts, waist-high and gnarled. And then it stops entirely, and the top 1,900 feet of the mountain is bare rock. No trees, no soil to speak of, nothing standing between you and the sky. That final third of the climb, the part that on the map looks like the home stretch, is the most exposed ground on the mountain, exactly where the wind is fastest and the temperature is lowest, and there is nothing at all to break the flow or give you a place to shelter. The tree line is not a scenic detail. It is the boundary of the death zone, as the death zone, and it sits far enough below the summit that people cross it while they still feel fine, while the danger is still an hour or two ahead of them, while turning around still feels like an overreaction. It is worth asking why the trees quit so low on this mountain, because at first glance a peak barely 6,000 feet tall in a temperate part of the country has no business having a tree line at all. Plenty of mountains at this latitude are green to their summits. This one is not. And the reason is the same reason everything else here is the way it is. The summit climate is not the climate of a modest New England hill. It is, in practical terms, the climate of the Arctic, dragged 1,000 miles south and stacked up into the sky, and trees simply cannot live in it. The growing season up there is too short, the wind too punishing, the ice too constant, and the thin scoured soil too poor for a tree to make a living, so the forest quits, and what takes over above it is a genuine alpine zone, a fragment of Arctic tundra sitting improbably in New Hampshire, home to fragile plants that survive here and almost nowhere else this far south, stranded on an island of cold since the last ice age. It is beautiful, and it is scientifically remarkable, and it carries a consequence that matters enormously to anyone caught out in it. In that bare tundra, there is nothing to navigate by. No trees to mark a corridor, no distinct features, just an open tilted plain of rock that looks the same in every direction, so the route across it is held together entirely by cairns, small, deliberate stacks of piled stones set at intervals to point the way. In clear weather, you walk from one cairn to the next without a thought. In fog, You go looking for the next one and it is simply not there, because it stands 50 feet off in a direction you cannot guess, and the trail, which was never a groove worn into the ground, but only a line connecting stones you can no longer see, ceases to exist. That is how people lose the path in the one place where losing it is most likely to kill them. And it is worth holding on to that image of a person standing among stacked stones in the fog, unable to see the next one. Because the very first death this mountain is remembered for happened exactly there, against a wall of piled stones, a short walk from a door. Cross that line on a bad day and add the last two ingredients, and the trap closes. The first is water. If your clothing is wet from rain or sweat or blowing snow that melts against your body heat and then refreezes, it stops insulating you. Worse, moving air strips heat away from a wet surface with brutal efficiency, far faster than from a dry one. And the wind here is never still. The heat pours out of you faster than your body can generate it, and that is hypothermia. And hypothermia's cruelest feature is that it attacks the organ you need to save yourself. As your core cools, your judgment degrades. You get clumsy, then confused, then strangely calm and content, and the decisions you make about whether to keep going or turn back, about which direction the trail is, about whether you are in real trouble, are being made by a brain that is already too cold to make them well. By the time the situation is obviously an emergency, the person inside it often can no longer tell. It is worth being specific about how a body fails in that cold, because the vagueness of the word hypothermia hides how orderly and predictable the collapse actually is. Your body runs a small furnace, turning food into heat to hold your core at around 98.6 degrees, and it defends that number ferociously, because the chemistry of staying alive only works inside a narrow band around it. When heat leaves faster than the furnace can replace it, the core temperature begins to drop, and it drops in stages that are grimly consistent from one person to the next. In the first stage, as the core falls a few degrees, you shiver hard, the body's automatic attempt to make heat by forcing the muscles to work, and your hands and feet go clumsy as blood is pulled inward to protect the heart and brain. This is the stage where good decisions are still possible, where turning back still works, where you are cold and miserable, but fundamentally still yourself. In the next stage, as the core keeps falling, the shivering grows violent and then, ominously, begins to fade, because the body is running out of the fuel to sustain it. Coordination collapses, speech slurs, and judgment, the one thing you need most, goes early and goes badly, replaced by confusion, apathy, and sometimes a strange, contented calm. People in this state have wandered off the trail, sat down to rest a few steps from safety, even started removing their own clothing, because a failing brain misreads the cold as heat. In the final stage, the furnace loses, consciousness fades, and the heart, chilled past what it can tolerate, slips into a rhythm it cannot recover from. On a bad day up there, the whole descent from clumsy hands to fatal can happen in a couple of hours. Now understand why the wind makes all of that so much faster, because this is the physical heart of the entire mountain. Heat leaves a warm body into cold air, mostly by warming a thin layer of air pressed right against the skin, a layer that, being slightly warmer, tends to linger and insulate you a little. Wind destroys that layer. Moving air strips the warmed film away the instant it forms and slams fresh cold air against you over and over, thousands of times a minute, so your skin never gets to sit inside even a sliver of its own warmth. That is convective heat loss, and it is exactly what the wind chill number measures, the effective temperature your skin actually experiences once the wind is hauling heat away at speed. A calm 10 below zero is survivable with decent clothing for a good while. 10 below in a 60-mile-an-hour wind pulls heat out of exposed flesh so fast that skin can freeze in minutes and a body can be overwhelmed in a fraction of the time it would take on a still day. And this mountain specializes in precisely that pairing, deep cold and hard wind arriving together, because the same weather pattern that delivers one delivers the other. The wind chill is not a separate danger stacked on top of the cold and the wind. It is the number that tells you what the cold and the wind do to you together. And on this summit, they are almost never apart. There is a second kind of cold injury braided through this whole story, and it is worth separating from hypothermia because it kills body parts rather than the whole person. Frostbite is the freezing of tissue itself, usually at the edges, fingers, toes, ears, nose, cheeks, the places farthest from the core, and first to be sacrificed when the body pulls blood inward to defend the vital organs. When the tissue gets cold enough, ice crystals form inside and between the cells, tearing them apart, and the blood vessels that feed the area clamp down and clot, cutting off the supply, so that even flesh that survives the initial freezing can die afterward from lack of blood. In the wind and cold this mountain produces, exposed skin can begin to freeze in minutes, and a hand bared to work a zipper or a knot can be ruined before the task is done. Hold that image, because it is going to come back on a January ridge, when a man takes off his mittens to help his friend and cannot get them back. The second ingredient is the one that ties it to that opening image of the woman by the cairn. Visibility. When the wind drives fog and snow across the summit, and it does this on more than half the days of the year, the world shrinks to a few feet. The heated building you are trying to reach, the road, the trail markers, the summit itself, all of it can vanish from 200 yards away. You can be close enough to the door to walk there in the time it takes to read this sentence and not know which way the door is because you cannot see it and you have no landmark and the wind is erasing your tracks behind you as fast as you make them. This is the answer to the question the hook left hanging, or at least the first layer of it. Distance is not measured in feet on this mountain. It is measured in what you can see and what your body can still do. 200 yards is nothing when you can see the door. 200 yards is infinite when you cannot, and when your legs have stopped answering, and when the wind is taking your heat faster than you can make it. And there is one more turn of the screw, the one that makes this a system, and not just a bad place to be caught out. If you get into trouble up there, the people who come to save you have to climb into the exact same wind that is killing you. Your distress signal, whether it is a shout, a flare, a radio call, or in the modern era, a satellite beacon that reaches a rescue coordination center in seconds, can travel at any speed. The rescuer cannot. The rescuer has to physically move a human body up through the same fog, the same cold, the same wind that stopped you, and the same physics that removed your options removes theirs. The signal is fast. The rescue walks. Keep that gap in mind, because we are going to watch it decide who lives and who dies across 170 years, and the gap does not close. Technology makes the signal faster and faster until it is nearly instantaneous, and the rescuer still walks, and the mountain does not care about the difference. That is the machine. Fetch feeds it. The range accelerates it. The pressure gradient sustains it. The tree line strips away all shelter. The fog erases the destination. The cold disables the brain. And the geometry of rescue means help has to enter the same trap to reach you. Now watch it work. Because the first people to live in the shadow of this mountain understood the machine long before anyone had a word for fetch or a way to measure a pressure gradient. And what they understood was not a list of facts. It was a discipline. The Abenaki, the indigenous people of this region, called the mountain Agiokochuk, a name usually translated as the place of the Great Spirit, or the home of the Great Spirit. And the relationship they had with it was not the relationship a modern hiker has with a summit to be bagged. The peak was not a destination to be conquered on a schedule. It was a presence to be read and respected. And by most accounts, the Abenaki did not casually climb to the top. It is easy for a modern person to file that under superstition, to hear place of the Great Spirit and imagine a taboo based on fear of the unknown, and to feel quietly superior about it because we have anemometers now. That would be a mistake, and it would be exactly the mistake this mountain punishes. Strip away the spiritual language and look at the behavior underneath it, and what you find is a sophisticated observational system encoded as culture. Generations of people living at the foot of that range watched the summit make its own weather. They watched clouds form on it out of a clear sky. They watched the top disappear while the valley stayed calm. They learned, without instruments, that the mountain operated by rules that did not match the rules down where they lived. And they built a practice around that knowledge, a practice that said, the summit is not a place you occupy. It is a place you read from a distance and approach with caution or not at all. That is not folklore standing in for science. That is field data, accumulated over centuries and passed down as respect, which is a very durable way to store a warning. There is a concreteness to that knowledge that gets lost the instant it is filed under legend. People living at the foot of the range, generation after generation, had a front row seat to something most visitors never linger long enough to notice, which is that the summit runs its own weather, independent of the valley below. No single person could hold a reliable model of a mountain that manufactures its own weather. But a culture could, spread across many observers and many lifetimes, and carried down as practice, as story, as the plain habit of caution, which is a remarkably durable and error-resistant way to store a warning, far tougher than any one expert's memory, and far harder to talk yourself out of in a weak moment. And the content of that stored warning was conservative by design. It treated the summit as dangerous by default, all the time, storm or no storm, and it did not wait for the danger to prove itself first. The visitors who came later reversed the default. They treated the summit as safe until something went wrong, and by the time something went wrong, they were already standing in the middle of it. A knowledge system that assumes danger keeps you home on the ambiguous days. A confidence that assumes safety walks you out onto the ridge to find out which kind of day it is. And from the bottom of this mountain, the ambiguous day and the lethal day look exactly alike. The crucial thing about that system is what it assumed. It assumed the mountain was dangerous on its own terms, that the danger was built into the place, and did not require a storm to be announced first, that the safest posture was restraint. It is a knowledge system organized around the idea that you adapt to the mountain rather than forcing the mountain to fit your plans. Remember that, because everything that goes wrong in the next 170 years goes wrong at exactly the point where somebody reverses it, where somebody arrives with a schedule, a sunrise to catch, a meeting to attend, a record to set, a route to finish, and decides that the mountain will accommodate the plan. The Abenaki restraint is the control condition. It is what caution looks like when it is built into the culture instead of learned from a body, and the danger it was responding to existed long before anyone had rope or wool or a weather forecast or a heated building at the top. The danger predates the equipment, which raises the obvious next question, the one that pulls us forward. What happens when people stop reading the mountain from a distance and start building on top of it? Because that is exactly what happened. By the middle of the 19th century, Mount Washington was not a place of the Great Spirit approached with caution. It was a tourist attraction. The White Mountains had become a fashionable destination for well-off travelers from Boston and New York, and the summit of the highest peak in the region was the prize. Bridle paths were cut up the slopes so that visitors could ride horses or mules to the top. And then someone built a hotel up there. Two of them, eventually, small stone and wood structures right on the summit, the most famous called the Tip Top House, opened in 1853 where a tourist could spend the night and watch the sun rise over the mountains from 6,000 feet. Think about what that did. It took a summit that indigenous knowledge said should not be casually occupied, and it put beds on it, and it advertised. It turned the most meteorologically violent point in the northeastern United States into an amenity. And the people it invited were by and large, by and large, not mountaineers. They were vacationers, in the clothing of vacationers, with the risk tolerance and the physical preparation of people going to a resort. The mountain had not changed at all. The audience had changed completely. That gap between what the mountain was and who was now standing on it is where the dying starts. And that gap was about to blow wide open because access was about to explode. When people first climbed to the tip-top house, they did it the slow way, on foot or on horseback up bridle paths, hours of hard effort that at least gave the weather time to warn them and gave them a body already working, already warm, already committed to the mountain. Then came the machines. In 1861, after years of construction, the Mount Washington Carriage Road was finished, a graded route all the way to the summit that carriages, and later automobiles, could climb under their own power. 8 years after that, in 1869, an inventor named Sylvester Marsh opened something stranger still on the western side of the mountain, a cog railway, a steam engine that hauled itself up brutally steep grades by biting a toothed rail with a gear, the first mountain-climbing cog railway in the world. Think about what those 2 feats of engineering did to the mountain's filter, the invisible thing that had always decided who got to stand at 6,000 feet. Before them, reaching the summit demanded real effort, and effort is a filter, weeding out the unfit, the unprepared, the casually curious. After them, you could ride to the top of one of the most violent small mountains on the continent in your street clothes, sitting down in an hour or 2, arriving at the deadliest altitude in the Northeast with a body that had done nothing to prepare and a wardrobe chosen for a pleasant summer outing. The road and the railway did not make the summit 1 degree warmer or 1 mile an hour less windy. They made it reachable by people with no earthly reason to suspect it was dangerous, delivered them straight to the ground where the mountain does its killing, and then, at the end of the day, carried the survivors back down before the second face ever showed itself. Every one of those thousands of safe round trips added another brick to the reputation of an easy mountain. And that reputation is precisely what walks the next set of victims into the open. Lizzie Bourne walked into that gap on the 14th of September, 1855. She was 23 years old, from Kennebunk, Maine, traveling with her Uncle George and her cousin Lucy. Their objective was simple, ordinary, and reasonable by the standards of a resort holiday. They wanted to reach the tip-top house at the summit, spend the night, and see the sunrise. They set out from a stopping point partway up the mountain, near the halfway house on the carriage road that was then still being built, in the early afternoon, somewhere around 2 o'clock. And on a summer resort holiday, on a mountain you drive up today, that is not an obviously insane decision. It is an afternoon stroll to a hotel. The carriage road was under construction and offered a graded path for part of the way. The distance to the summit was only a few miles. They had daylight. They had, in their minds, plenty of margin. What they did not have was a guide, and what they did not understand because nobody had built the cultural memory into them the way the Abenaki had built it into their descendants, was that the mountain measures margin differently than the valley does. They were also arriving with an assumption baked into the whole trip, the assumption that proximity to shelter is the same as safety. The hotel was up there. They were walking toward the hotel. As long as they kept climbing, they were getting closer to warmth and beds and light, and closer, in their minds, to being safe. It is one of the most natural assumptions a human being can make, and on this mountain, it is a lie, and Lizzie Bourne is the proof. The first warning came the way the mountain's warnings always come, as weather that arrives faster and harder than a flatlander expects. As the afternoon wore on, the wind rose, and a cold rain began to drive across the upper slopes. This was the mountain switching personalities, the summer resort becoming the Arctic engine, and it did not take a named storm to do it. Just an ordinary deterioration of an ordinary September day. To an experienced mountain traveler, wind and cold rain above the tree line in the late afternoon with the summit still ahead is an unambiguous signal to turn around now, while turning around is still cheap. To 3 tourists who had already come a long way and could surely see in their minds that the top was close, it read as discomfort to be pushed through. They interpreted the warning as an obstacle rather than a verdict. They kept climbing. And here the mountain applied its particular cruelty, the one built into the geometry of an out-and-back climb. As they pushed higher and the light began to fail, the option to retreat quietly closed, not because anyone blocked it, but because retreat had become just as long, just as cold, and just as exposed as pressing on. When you are halfway between the shelter you left and the shelter you were trying to reach, going back is not safer than going forward. Both directions are the full length of the danger. That symmetry is a trap because it removes the psychological escape hatch. There is no obviously safe direction anymore, so the natural human move is to keep going toward the destination you actually wanted, which is up, into the worst of it. Daylight was gone. The wind was full. And the one option that mattered most, the ability to see where they were going, was gone with the light and the fog. They tried to keep moving toward the summit in the dark, into the wind. And at some point in the evening, near the top, they could go no farther. They stopped. The 2 men and the young woman took what shelter they could find against a low wall of piled stones, a stock enclosure, or a rough wind barrier, and they waited, because there was nothing else to do. And here is the detail that has haunted this mountain for 170 years. They were, at that moment, only a few hundred yards from the tip-top house. Some accounts put it closer, some farther, and the sources genuinely disagree on the exact distance, whether it was a couple hundred feet or a few hundred yards, and it is worth being honest that we do not know the number precisely. But the order of magnitude is not in doubt. They were close. They were within a short walk of a heated building full of people. They could not see it, and they did not know it was there. In the dark, and the wind, and the cloud, and so it might as well have been on the far side of the country. Lizzie Bourne died beside that wall at around 10 o'clock at night. Her uncle and cousin survived the night huddled against the same stones, and at first light they saw where they were. The building had been just above them the whole time. When the light came up on the 15th of September, and George and Lucy Bourne finally saw where they had spent the night, the shape of the trap was laid out in plain daylight in front of them. They had stopped, exhausted and blind, against a low wall of piled stones that was itself part of the summit's works, and the tip-top house stood just above them, close enough that on any clear morning a person could have called out from that wall and been heard at the door. They had been that close all night long. In the dark and the driving cloud, they had had no way to know it. No landmark, no glimpse of a lamp, nothing at all to tell them that the thing they were dying to reach was a short walk uphill. The 2 survivors made it up to the building that morning, carrying with them the knowledge that the distance which had killed Lizzie Bourne had never really been a distance in any meaningful sense. It had been a curtain. The feet were nothing. The visibility was everything. That is the insight this first death drove into the record of the mountain, and it is the exact one the place would spend the next century and a half proving again, with fitter people, better equipped people, and better warned people. The point of no return for Lizzie Bourne had not come at the summit, or on some obvious knife edge of danger where a reasonable person would have known to stop. It had come quietly, in the late afternoon, at the ordinary moment when retreat stopped being shorter than the way forward, and every single step after that had carried her deeper into a trap whose door she could no longer see. There are pieces of this story that we have to hold loosely, and it matters that we do, because the whole point of this mountain is to resist the tidy explanation. Lizzie Borden is often described as the first recorded death on Mount Washington, but she was not. Frederick Strickland, a young Englishman, died on the mountain in October of 1849, 6 years earlier, caught by a storm and lost while descending. Which of them counts as the first depends on how you are counting and which records you trust, and the two names are often swapped in the retelling. There is also a persistent claim that Lizzie Borden had a heart condition that contributed to her death, that her heart gave out under the exertion and the cold. It may be true. It is plausible. It is not confirmed, and it should not be handed to you as fact, because it does a subtle disservice to the real lesson. If she died because of a weak heart, then the story becomes about her particular fragility, a medical footnote, something that would not happen to a healthy person. And that is precisely the comforting misreading this mountain sets you up for. Because the thing that killed Lizzie Borden was not her heart. It was 200 yards of zero visibility between a living person and an open door. Her body simply reached its limit before her uncle's did. Proximity was not safety. The building was right there, and right there was not close enough. So the natural response, the one almost everyone has when they first hear the Lizzie Borden story, is to quietly explain it away. She was a tourist. She was unprepared, out of her depth, in the wrong clothes, on a mountain she did not respect, and if she had a heart condition on top of that, well, there you go. A fit person, a real athlete who knew the mountains, who read the weather correctly and made good decisions would never end up frozen against a wall a few hundred yards from a hotel. Surely fitness solves this. Surely competence solves this. That is the reasonable next thought, and this mountain has an answer for it. And the answer is two dead athletes at the height of summer. William Curtis and Alan Ormsby were not tourists. They were among the most accomplished endurance athletes of their era. Curtis was a founding figure in American amateur athletics, a champion in multiple disciplines, a man who had spent decades in serious physical pursuits and helped organize the sport of track and field in the United States. Ormsby was younger, strong, an experienced climber. Both were members of the Appalachian Mountain Club, the AMC, the organization that had by then made itself the steward of these peaks. On the 30th of June, 1900, they set out to climb Mount Washington to attend the club's annual gathering at the summit. This was their world. They knew the trails. They knew the mountain's reputation. They were fit in a way that Lizzie Borden, on a resort holiday, simply was not, and they were climbing in late June, when the valleys below were in full summer. If competence and fitness and knowledge were the answer, these two men were the answer walking up the hill. They chose the Crawford Path, the oldest continuously used hiking trail in America, which runs along the high ridge of the Presidential Range toward the summit, spending mile after mile above the tree line on exposed ground. And as they climbed into that exposed country, the weather turned, the way it does, and here is the part that separates them completely from the tourists. They saw it. They read it correctly. We know this because they wrote it down. In the trail register on Mount Pleasant, one of the peaks along the ridge, Ormsby left an entry noting rain, clouds, and a wind of 60 miles an hour, and the single word, cold. That is not the note of a man who misjudged the mountain. That is an accurate field observation of deteriorating conditions above the tree line, made by someone who understood exactly what he was looking at. They read the mountain right. And then they kept going anyway because they were fit, because the summit was close, because they were strong enough to believe they could push through what would stop a weaker party. Their fitness did not save them. Their fitness is what carried them deep enough into the trap to die there. faster and farther than a slower party would have gone before turning back. The storm they had walked into was not an afternoon squall. It was a sustained assault that battered the summit for something like 60 hours, and the ice it deposited on the summit buildings was measured not in a dusting, but in inches. Thick armor of rime, built up by supercooled fog freezing on contact with every surface. Somewhere along that high ridge, in the wind and the cold, William Curtis went down and died. His body later found near the lakes of the clouds, the small alpine tarns that sit in a shallow saddle below the summit cone at around 5,000 feet. Ormsby kept going. He got closer. He got, by the accounts of those who found him, within a few hundred feet of the summit before he too collapsed and died. Within a few hundred feet. The same distance, in essence, that killed Lizzie Bourne 45 years earlier. The same margin of almost the same last stretch of open rock that a person can see across on a good day and cannot survive on a bad one. And when the searchers from the summit house tried to go out and find them during the storm, the mountain showed them the rescue geometry directly. The men who went out to search were driven back after only about 100 feet. 100 feet. They could not push their own bodies more than 100 feet from the door into that wind, which tells you with brutal precision what Curtis and Ormsby were fighting out on the open ridge. And it tells you the thing this whole story keeps circling back to. The rescuer faces the same wall as the victim. The summit house was full of people who wanted to help, warm and sheltered and close, and the mountain would not let them cross 100 feet of ground. The signal that two men were in trouble meant nothing, because the wind held the rescuers at the door. There is a detail in how the two were found that says everything about the trap they walked into. Ormsby's body lay higher on the mountain than Curtis's, closer to the summit, and that geometry tells the story without a word of testimony. When Curtis gave out somewhere near the lakes of the clouds, Ormsby did not stop with him. He went on, alone, into the worst of it, almost certainly trying to reach the summit buildings and bring back help for his companion. And he got agonizingly close, within a few hundred feet of shelter and warmth and other living people, before the same wind took him too. Read the sequence, and you watch the objective change in real time. From a pleasant summer climb, to a club meeting, to a desperate effort to save a friend, to a solitary struggle to cover a few hundred feet of ground that on a calm day is a 2-minute stroll. That is the whole machine of this mountain compressed into a single afternoon. A reasonable plan, a correct reading of the weather, a deliberate decision to continue, the loss of one companion, an active attempt to get help, and a point of no return reached not in some dramatic instant, but in the slow accumulation of cold across a body that kept moving until it simply could not move anymore. When the weather finally eased enough to let searchers bring the two men down, they were carrying bodies off a ridge the living could barely cross. And that calm note Ormsby had penciled into the register on Mount Pleasant, the 60-mile wind and the single word cold, stopped being a weather observation the moment they found him and became something closer to a verdict he had written on himself, in his own hand. Having understood exactly what he was looking at and gone forward into it anyway. Now sit with the reversal, because this is one of the load-bearing turns of the whole story. It was June, not January, not a freak February Arctic outbreak. Late June, the doorstep of summer, when the valleys were warm and green, and nobody thinks of a New Hampshire mountain as a place that can kill a champion athlete by freezing. The mountain does not observe the calendar. The summit weather is not a seasonal visitor that shows up in winter and leaves in spring. It is a permanent condition of that altitude and that geography, and it can manufacture a lethal, ice-armored 60-hour storm in the last week of June and drop it on top of two of the fittest men in the country, The date on the calendar is one more piece of false comfort that the mountain strips away. Summer is not safety here any more than proximity is. The AMC's response to the deaths of Curtis and Ormsby is where the story takes its most important structural turn, because it is the first time we watch a solution create the next problem. The club looked at what had happened, two of its own members dead on the exposed ridge below the summit, unable to find shelter in a storm, and drew an entirely sensible conclusion. The upper mountain needed a refuge, a place where a party caught out by weather on that long, exposed traverse could get out of the wind and survive. So they built one near the Lakes of the Clouds, close to where Curtis had fallen. It began as a simple stone shack in 1901 and grew, by 1915, into a substantial stone hut, the Lakes of the Clouds Hut, which still stands today as the largest and highest of the AMC's mountain huts. On its own terms, it was a good and humane decision, and over the decades that hut has unquestionably saved lives, giving shelter to people who would otherwise have been caught in the open. But watch what the fix actually did to the system. A shelter high on the mountain does not just protect the people who are already up there. It changes the calculation of everyone deciding whether to go up at all. It extends the reach of the ordinary hiker. It makes the exposed traverse feel survivable, because now there is a building in the middle of it, a place to aim for, a safety net. And a safety net reliably encourages people to go higher, to attempt more, to accept a little more risk than they otherwise would, because the consequences of a mistake feel bounded. The hut invited more people onto the very ground that had just killed two experts. This is not an argument that building the hut was wrong. It is an observation about how safety infrastructure behaves on a mountain like this one. Every improvement that makes the summit more reachable also makes it more crowded with people who are reachable precisely because they are less prepared. The road did it. The railway did it. The hotel did it. And now the shelter did it too. Each fix pulls the next set of victims a little higher up the slope. Hold that thread. The question of what the AMC's shelter actually changed, because it returns 80 years later, on a winter night, at a locked and shuttered hut, with a body it could not save. While the hut was being built and the tourists kept coming, something else was taking shape on the summit, something that would eventually turn this mountain from a local hazard into a place with a number attached to it, a number that people around the world would recognize. In 1932, a small group of scientists established a permanent weather observatory at the very top of Mount Washington, in one of the old summit buildings, and committed to doing something that sounds simple and is actually a kind of quiet heroism. They committed to staying up there through the winter, year-round, in shifts, and taking measurements. Every hour, around the clock, in whatever the mountain was doing, someone would record the temperature, the pressure, the wind. And to measure the wind, you cannot sit inside by the stove. You have to go outside, to the instruments, and in the conditions this mountain produces, going outside is the entire danger of the mountain concentrated into a short walk. The observatory turned the act of measurement into an act of exposure, deliberately, on purpose, every hour, forever. Which is why the mountain's most famous moment happened not to a lost tourist or a stranded climber, but to men whose job was to walk out into the worst of it and write down what it was doing. The people who signed up for that duty were a particular kind of stubborn. The observatory was put on a permanent year-round footing in 1932 by a small group of committed men, among them Joe Dodge, Robert Monahan, Alexander Mackenzie, and Salvatore Pagliuca, working out of a low building lashed to the summit rock with chains and cables, so the wind could not simply shove it off the mountain. Their instruments had to survive conditions that destroy ordinary equipment. An ordinary spinning cup anemometer ices up and stops turning in the rime, which is why the observatory came to rely on heated instruments and, in the modern era, on a pitot-static anemometer, a design borrowed from aircraft that measures the wind by the pressure it exerts rather than by a delicate moving part left exposed to the ice. Even so, the ice wins often enough that the job still includes going outside to clear it by hand, exactly as it did on the day of the record. The daily routine has barely changed in principle across 90 years. On the hour, every hour, someone records the numbers. And taking the wind and checking the instruments means opening the door and stepping into whatever the mountain is doing. Clipping into fixed ropes in the worst of it, chipping rime off the sensors, and coming back in to write it all down. The observatory calls the summit the home of the world's worst weather. You can argue about that superlative, and people who study Antarctica and the high Himalaya reasonably do. So it should not be handed to you as settled fact. But the claim rests on something concrete, a combination of extreme wind, extreme cold, dense rime icing, and near constant whiteout, all of it sitting in a place accessible enough that human beings have stood in it and measured it continuously for the better part of a century. Most of the planet's genuinely more violent spots have never had anyone living on top of them year-round to keep the record. This one has. That is part of why we know so precisely how dangerous it is, and it is worth saying plainly that the measurements which prove the danger exist only because people volunteered to be exposed to it, on the hour, forever. The 11th and 12th of April, 1934, produced the day this mountain is best known for, and the setup was a meteorological perfect storm in the most literal sense. The observatory crew that winter included Salvatore Pagliuca, Alexander Mackenzie, and Wendell Stevenson, along with others cycling through. The weather pattern that assembled itself over the northeastern United States on those 2 days was the machine running at full power. A low-pressure system had split into what forecasters call a double-barreled low, one center over the Great Lakes and another over the Carolinas, and both of them were feeding into the same broad circulation, while a powerful high-pressure system anchored itself to the west. That arrangement packed an enormous pressure gradient across New England and aimed the resulting wind straight at the presidential range, and the Venturi throat above the summit did what it always does, with fast, clean air. It accelerated it beyond anything in the instrumental record. It is worth pausing on what a number like that actually means, because 231 miles per hour is so far outside ordinary experience that it barely registers as a real figure. A hurricane is rated as catastrophic, a Category 5, the very top of the scale, once its winds pass about 157 miles per hour. The wind on the summit that afternoon was not a strong Category 5. It was roughly half again as fast as the threshold for the most destructive storms the tropics can produce, and it was doing it on a mountaintop, in April, over frozen ground. Wind like that does not merely knock a person down. It drives rime ice horizontally like birdshot. It can peel boards off a roof. It turns anything loose into a projectile, and it presses on a standing structure with a steady force that would pull an ordinary building apart at the joints. The observatory survived it for one reason, and that reason is the whole character of the place. The building had been deliberately chained and cabled down to the summit rock, anchored against precisely this, because earlier structures up there had already taught the brutal lesson of what the wind does to anything it can get its shoulder under. So while the gauge outside was clocking the strongest wind ever measured by human beings, the crew was inside a shuddering box lashed to the mountain, listening to the whole structure strain against its anchors, and still opening the door on schedule to keep the record, because a reading you do not take is a reading that never existed. And keeping that record, in the end, came down to a man with a wooden club climbing onto a roof. The anemometer they were relying on, the heated number 2 anemometer, was accumulating rime ice despite the heating, because the supercooled fog was freezing onto it faster than the heat could shed it, and ice on the cups makes the reading wrong. So Wendell Stevenson went outside, into a wind already blasting well past 100 miles an hour, climbed up to the instrument, and knocked the ice off it by hand with a club so that it would keep turning true. Read that again and let it land. The record that made this mountain famous exists because a man physically went out into a 200-mile-an-hour environment and beat ice off a spinning instrument with a stick so the number would be accurate. The data did not fall from the sky. Someone went and got it, at the exact moment that going outside was most likely to kill him. At 1:21 in the afternoon on the 12th of April, 1934, the anemometer clocked a wind speed of 231 miles per hour. The observers, who had been watching the numbers climb all day, knew immediately what they had, and they knew equally well that nobody would take their word for it. In the log, the note that survives captures the whole thing in 4 words. Will they believe it? Not celebration, not fear. A working scientist's dread that the most extraordinary measurement of his career would be dismissed as a broken instrument. And they had reason to worry, which is why what they did next matters as much as the number itself. They did not just report it, they preserved the evidence. The anemometer was later sent to be checked and calibrated, its accuracy confirmed, and the reading was verified by the United States Weather Bureau. 231 miles per hour stood for over 60 years as the highest surface wind speed ever measured by a human being anywhere on Earth, until an unmanned instrument recorded a higher gust during a tropical cyclone off Australia in 1996. To this day, it remains the highest natural surface wind speed ever observed by people who were actually standing there. That number did something the men who recorded it could never have planned for. It took a remote scientific outpost, only 2 years into its permanent life and chronically short of money, and made it a place the entire country had heard of. Overnight, the observatory had an identity, a claim to fame, a reason for people to care whether it survived at all. And that reputation is a large part of why there is still a crew living up there today, decade after decade, taking the same hourly readings in the same impossible weather. The wind that might have been the end of a fragile little station instead guaranteed its future. And that future is precisely why we can speak with such confidence about the deaths that came after it, because from 1934 onward, there was always someone stationed on that summit, in every season, writing down exactly what the mountain was doing on the very day it did it. The record did not just measure the danger. It paid for the witness who would record all the danger still to come. And now the reversal, that is the entire point of the 1934 story, the one that reframes everything you assume about this mountain. On the day of the record, the day of the 231-mile-an-hour wind, nobody died. Nobody was even seriously hurt. The most violent wind ever measured by a human being on the surface of the planet blew across that summit, and its death toll was 0. Why? Because everyone who might have been in danger was inside, or knew better than to be on the mountain at all. The observers were sheltered in a building chained to the rock with cables, riding it out. There were no tourists, because you would have to be out of your mind to be climbing on a day like that. And the ones who go out of their minds mostly do it on days that look fine. The record wind is, in a strange and important sense, the least dangerous weather this mountain produces, precisely because it is so obviously, spectacularly deadly that it clears the mountain of everyone who could be killed. Nobody stands under an avalanche that is visibly falling. The 231-mile-an-hour day announces itself days in advance and empties the slopes. The mountain does its killing on the ordinary bad day, the Tuesday that starts clear and turns. The June afternoon, the forecast that says unpleasant instead of lethal. The day that looks survivable, that looks like a reasonable window, that lets people onto the upper mountain feeling fine and then closes around them when they are already committed and already cold. The record is a spectacle. The killer is the day nobody puts in a book, the day that does not set a record, the day whose wind tops out at a mere 70 or 80 and finds someone already out on the open rock with wet clothes and failing judgment. This is not a rhetorical flourish, it is the actual pattern in the record. The people who die on this mountain overwhelmingly die on days that looked manageable from below, days with a forecast a reasonable person could talk themselves past, days that gave no spectacular warning because there was nothing spectacular to see until it was already too late. A 70-mile-an-hour wind does not make the news. It does not empty the trailheads. It sits right in the band where a fit, determined person with decent gear looks at it and thinks, I can handle that, and is correct, right up until the wet clothing and the wind and the failing light and the vanishing trail all line up against a brain that has quietly gone too cold to add them together. The record-setting days protect people by terrifying them into staying home. The ordinary bad days kill people by reassuring them into going out. That is the inversion sitting at the very heart of this place, and it is the reason the number 231, for all of its fame, has never once appeared on a death certificate. If you remember one thing about the number 231, remember that it is the safe number because it is the honest one. The dangerous numbers are the ones that lie about what they are going to become. And that sets up the hardest cases on this whole mountain, the ones where the people involved had every skill, every piece of equipment, and read the mountain correctly. And it still was not enough. What happens when real technical expertise meets an ordinary bad day? That question walked up the mountain on the 22nd of January, 1982, in the persons of Hugh Hare and Jeff Batzer, two young, gifted, ambitious climbers. Hare, in particular, was a prodigy, one of the best rock climbers in the country at 17, the kind of natural talent who had been climbing hard routes since childhood. Their objective was Odell's Gully, a steep ice and snow climb in Huntington Ravine, one of the serious technical alpine venues on the eastern side of Mount Washington, a place real climbers go to test themselves in winter conditions. This was not a tourist mistake. This was two skilled alpinists doing exactly the kind of thing their skill was built for. And their competence showed immediately in a way that should have been reassuring and instead became part of the trap. They climbed Odell's Gully fast, in something like 90 minutes, a strong time. They were so confident, moving so well, that they left some of their gear behind to travel lighter and faster. Speed was the plan. Speed was the safety margin. And on this mountain, as we have already seen with two dead athletes on a June ridge, speed and fitness are the tools that carry you deepest into the trap before it springs. The weather turned into a full blizzard, and now the same mechanism that killed Curtis and Ormsby and Lizzie Bourne activated. The erasure of the world, the loss of the ability to see where you are and where you are going. Hare and Batzer, coming off their climb into deteriorating visibility, made a navigational error, the kind of error that is almost impossible to avoid when the whiteout removes every reference point. Instead of descending the way they had come, back toward the safety of Pinkham Notch, they went down the wrong side into the Great Gulf, a huge, remote, trackless glacial cirque on the northern side of the mountain, a place that funnels you away from help and into deep snow and brutal cold with no easy way out. It is worth understanding how easy that error is, because it is the same blindness that runs through every death on this mountain, turned this time to navigation. Come off a climb like Odell's Gully into a whiteout, onto the broad, featureless roof of the upper mountain where the cairns have dissolved into cloud, and you have no way to tell one direction of gentle downhill from another. Both feel like descent. Both feel like the way home. But the drainages on this mountain run opposite ways, and the slope that leads back down toward the road, and the slope that pours into the Great Gulf Part Company only a few degrees apart at the top. So a party off by that small angle at the very start walks steadily, confidently, downhill into the wrong world. By the time the ground around them made it plain, they were not where they believed. The correct descent was far behind and above, and the Great Gulf already had them. One wrong turn in a whiteout, and a routine descent had become a wilderness survival ordeal in the worst of winter. They were now going to spend 3 nights out, in temperatures that dropped to around 20 below zero before the wind was even counted, with reduced gear, injured and freezing, in one of the most inaccessible pockets of the mountain. 3 nights out is not a number. It is an ordeal that has to be survived hour by hour, and the way it had to be survived tells you how completely the objective had changed. When Hare and Batzer set out that morning, the goal was a hard, elegant ice climb done fast and light, the kind of thing that makes a young climber's reputation. By the first night in the Great Gulf, the goal was simply to live until morning, and everything they had done for speed now counted against them. The gear left behind to move quickly, the light packing that made perfect sense for a day climb and no sense at all for a survival bivouac in the deep cold. They were in a place with no trail, no shelter, and deep, unbroken snow, a bowl that funnels away from help rather than toward it, and they had to stop and wait because moving in the whiteout had already cost them everything once. So they waited in cold that fell toward 20 below before the wind was even added, doing the only thing there was left to do, conserving what heat they could and hoping the weather would break and someone would come. And while they waited, the cold was doing its patient work on their hands and their feet, the tissue at the edges freezing solid as their bodies pulled blood inward to defend the heart and the brain, the exact machinery of frostbite grinding forward night after night, quietly converting living flesh into tissue that would not survive. This is the particular cruelty of an exposure ordeal that does not kill you outright. You can win the fight to stay alive and still lose parts of yourself to it, because the body's own defense, sacrificing the extremities to protect the core, is the very thing that dooms the extremities. Across those 3 nights, Hare and Batzer were, in the most literal sense, trading their hands and feet for their lives, and the mountain did not give them any say in the terms. The search for them is where this story becomes something larger than 2 climbers in trouble, because it is the story that proves, more completely than any other, that on this mountain, the rescue is itself a lethal exposure. As word spread that Hare and Batzer were overdue, the Mountain Rescue Service, the volunteer organization of experienced climbers who respond to emergencies in these mountains, mobilized to search for them. Among the volunteers was Albert Dow, 28 years old, an experienced and well-liked member of the mountain rescue community, exactly the kind of skilled, committed person a place like this depends on. On the 25th of January, Dow and another rescuer, Michael Hartrich, were searching in the area below Lionhead, following what appeared to be tracks, pushing through the same storm that had swallowed the men they were looking for. And the mountain, which had spent 130 years killing the people who came to enjoy it, killed one of the people who came to save them. A slab of snow released above them, an avalanche perhaps 300 feet across, and it caught Albert Dow and killed him. Hartrich, his partner, survived. To understand how a search on foot turns into a death, you have to understand what the wind does to snow on this mountain, because it is the same wind, doing a different job. The great glacial ravines that scoop into the eastern side of the mountain, Huntington and Tuckerman, sit in the lee of the summit, sheltered from the direct blast, and the relentless wind that scours loose snow off the exposed upper cone has to put it down somewhere. It puts it down into those ravines and onto the lee slopes, packing it into dense, cohesive slabs, sometimes many feet thick, layered over weaker, looser snow buried beneath. A wind slab like that can sit quietly for days, looking perfectly solid, until something changes the balance: a fresh load of snow, the weight of a person, a small collapse in the fragile layer underneath, and then the whole slab releases at once, fracturing across a wide line and sliding as a single enormous mass. That is a slab avalanche, and Tuckerman and Huntington are among the most active avalanche terrain in the eastern United States for exactly this reason, because the summit wind spends the entire winter loading them, shovelful by shovelful. So the rescuers searching those slopes for Hare and Bottser were not only fighting the cold and the wind and the dark and the failing light, they were walking across loaded avalanche terrain in the middle of a storm that was actively building more of it. And the slope above Albert Dow and Michael Hartrick chose that moment to let go. This is the trap closing on the wrong person entirely. The two climbers up in the Great Gulf were dying of the wind. The rescuer looking for them was killed by the snow that same wind had piled up. There was no safe way to be on that mountain that night, not for the lost and not for the ones searching. And the accident reports are honest about that. They do not treat Dow's death as a freak accident. They treat it as the mountain doing exactly what the mountain does. Dow died searching for two strangers on a mountain in a blizzard, and his death is the purest statement of the rescue geometry this whole story has been building toward. The signal for help went out. The rescuer answered it, and the wall that stopped the victims killed the rescuer instead. Hare and Bottser were found on the third day, and even the finding carries the mountain's signature, the way it refuses to let rescue be clean or heroic in the Hollywood sense. They were not found by a helicopter sweep or a massive coordinated line search reaching its dramatic climax. They were found by an AMC employee who happened to be out on the mountain on a personal outing following a set of tracks, who came upon them alive, but only just, and at a terrible cost. Both men were catastrophically frostbitten from 3 nights in that cold. Jeff Bottser lost a leg below the knee, a foot on the other side, several fingers and toes. Hugh Herr lost both legs below the knee. 17 years old, one of the most promising climbers in America, and the mountain took his legs. The documentation for all of this is solid and worth naming, because this is recent enough that we are not relying on legend. The American Alpine Club accident reports, the accounts from the Mountain Rescue Service, and the reporting in the local Union Leader newspaper lay out the sequence. This is not folklore. This is a paper trail. There is a coda to the Hare and Bottser story that the mountain did not write, but that grew out of it. And it belongs here because it is the one place in this whole grim account where the trap produced something other than a grave. Hugh Herr did not quit. He became a scientist and an engineer, one of the world's leading designers of robotic prosthetic limbs, building the very technology that would let people who had lost legs, including himself, walk and even climb again. The mountain took his legs, and he spent his life answering it by rebuilding legs for everyone. That does not undo Albert Dow's death, and it does not soften what happened in the Great Gulf, but it is a fact, and it is a true one. And this account would be dishonest to leave it out, just because the rest of the story is so dark. It is fair to ask what a death like Albert Dow's actually changed, because a responsible account does not simply stack up bodies, it asks whether anyone learned anything, and some things genuinely did change. The avalanche that killed Dow was not so much a mystery to be solved as a hazard to be mapped. And in the decades since, the Forest Service established regular avalanche forecasting for Tuckerman and Huntington, so that anyone heading into those ravines can now check a daily advisory rating the very slopes that buried him, the same way skiers check conditions out west. The volunteer rescue services grew more organized, better equipped, better trained, more disciplined about when to commit people to loaded terrain and when to hold them back. Those changes are real, and they have saved lives. But notice what they can touch and what they cannot. They make the people going up better informed and better prepared, which is exactly where a fix can do some good. They do not move the ravines out of the lee of the summit, or stop the wind from packing them with snow all winter, or change the fact that a rescuer still has to walk into the same country that killed the person they went in to find. The advisory can tell you the slope is loaded. It cannot unload it, and it cannot come with you. So expertise did not solve the mountain. The best young climber in the country lost his legs, and a skilled rescuer lost his life on an ordinary bad day in January. But surely, you think, the problem was information. Hare and Batzer got caught by weather that turned on them, by a whiteout they walked into. If they had known what was coming, if the forecast had been better, if they had been warned in advance about exactly how bad it was going to get, they would have stayed home. Better forecasting will fix this. Give people accurate, specific, advance warning of lethal conditions, and they will not be up there when the conditions arrive. It is a reasonable hope. It is probably the most reasonable hope in this entire story. And the mountain answers it 12 years later with two experienced winter mountaineers who had a correct, specific, alarming forecast a full week in advance, and who died anyway. And that forecast was not some vague regional prediction that happened to mention the mountains in passing. By the 1990s, the observatory on the summit was issuing a specialized forecast for the higher summits themselves, written by people who lived in that weather and understood exactly how the alpine zone differs from the valley, produced precisely so that climbers could know, before they ever started up, what the top of the mountain was about to do. This is the fix working as designed. The information problem that killed people in the earlier eras, the summit turning lethal without warning, had been genuinely and substantially solved. A person planning a winter traverse in 1994 could learn, days out, that a brutal Arctic event was bearing down on the exact ground they meant to cross. The knowledge existed. It was accurate. It was available. And here is the hard thing the mountain keeps teaching. The thing no amount of forecasting skill can touch. A forecast is information. It is not transportation, and it is not a decision. It can tell you the storm is coming. It cannot make you stay home, and it cannot carry you off the ridge once you are standing on it. A forecast competes, every single time, against the reasons a person wanted to go in the first place, the trip already planned, the partner already committed, the belief that skill and speed can thread the gap, the plain human reluctance to waste a hard-won window of days off. Better forecasting shrank the gap between not knowing and knowing down to almost nothing. It did nothing whatsoever to the gap between knowing and choosing, and nothing to the gap between choosing to leave and being able to leave. Tinkham and Haas had the knowledge. What they did not have, once the ridge and the wind had them, was a way out that any amount of knowledge could provide. In January of 1994, Derek Tinkham and Jeremy Haas set out to do a winter traverse of the Northern Presidential Range, the high-exposed ridge that runs over the peaks, named for American presidents, north of Mount Washington itself. Both were experienced. Both were committed winter mountaineers who understood the terrain and the season. And crucially, they had the forecast. Extreme cold and extreme wind had been predicted for that stretch, and the prediction was not vague. It was there, days out, exactly the kind of advance warning that was supposed to be the answer to 1982. They knew a savage Arctic outbreak was coming. They went anyway, deliberately, traveling light and fast in the alpine style, leaving heavier gear behind to move quickly across the ridge, betting that speed would get them through the exposed section before the worst of it, or that their skill and fitness would carry them. It is the same bet Hare and Batzer made, the same bet Curtis and Ormsby made, the bet that competence can outrun the mountain. And the forecast they had, the very thing that was supposed to save them, did not change the bet. It just meant they made it with their eyes open. The mechanism that killed on this trip is one of the most important in the whole story, because it exposes a flaw in the fix itself, a limit on what a forecast can actually do. Haas later described it in the American Alpine Club accident report, and his description is one of the clearest windows into how this mountain closes its trap. As the conditions came on, full and brutal, out on the exposed ridge, they found that retreating was not an escape, it was a second hazard. In his words, to turn around would have led them directly into the wind, so they had to keep going forward. Think about what that sentence means. The wind was coming from a direction that made going back worse than going on. Retreat meant turning your face and your body straight into the full blast of a wind that could freeze exposed flesh in under a minute, while going forward at least kept it at your back or your side. The escape route required walking into the killing wind, so the forecast had told them the storm was coming, and they had believed it, and they had come anyway. And now the storm was here, and it had taken away the one thing a forecast is supposed to protect: the ability to leave. A correct forecast is worthless without escape geometry. Knowing the storm is coming does not help if, once you are in it, every direction out of it runs through the worst of it. Derek Tinkham could not go on. Somewhere on Mount Jefferson, in that Arctic wind, his body was failing, and Jeremy Haas made a decision that people have argued about ever since. He got Tinkham into a bivouac sack, a thin emergency shelter, to try to protect him, and to do it, Haas had to take off his mittens to work with his hands. In that cold and that wind, bare hands are a countdown. He lost the mittens to the wind, and then, with his hands freezing, having done what he could for his companion, Haas made the choice to go on alone toward the summit of Mount Washington and the observatory to get help, because staying meant 2 dead men instead of a chance at 1 rescue. He crawled the last of the way, hands ruined, and reached the observatory building at the top, and he banged on the door. Inside, 2 of the observatory staff, Ken Rancourt and Ralph Patterson, heard the banging over the wind, which is itself remarkable given what the wind was doing, and they got him inside. The wind that night peaked at 103 miles per hour, and the temperature held at around 40 below zero from midnight until 4 in the morning. Cold so deep and wind so strong that even the rescue that Haas had crawled to summon could not immediately go out. Because here is the final turn of the 1994 story, the rescue geometry again, absolute and unmovable. Jeremy Haas had made it to the door. Help was, in one sense, right there. But help could not reach Derek Tinkham, out on Jefferson in that wind, until conditions allowed, and they did not allow for days. Rescuers could not get to Tinkham until the following Sunday. The signal had arrived. A living man had physically dragged himself to the observatory and told them exactly what had happened and roughly where his partner was, and the mountains still would not let anyone cross the distance to reach him in time. Tinkham died out there. A correct forecast believed did not save him. A companion who survived and summoned help did not save him. The observatory staff, warm and skilled and willing, a short distance away, could not save him because the same wind that killed him held everyone else at the door, exactly as it had held the searchers to 100 feet in 1900. It is worth running this one through the machine because every stage of it is visible in a way it rarely is. The objective was a light and fast winter traverse of the northern peaks, serious but reasonable for 2 experienced mountaineers. The condition of control was genuine. 2 fit men who knew the terrain and had studied the forecast. The warning was not subtle. A predicted Arctic outbreak, days out, unmistakable. They read it correctly and went anyway, betting their speed against it. And the pressure behind that bet was the whole philosophy of the trip, the belief that moving light and fast was itself the margin of safety. The option they lost was retreat, and they lost it to geometry because the wind sat where going back meant walking into it. The attempt to regain control cost Haas his hands, and the cruel second complication was that those ruined hands were now the only thing left that could go for help. The point of no return came somewhere on that ridge in the dark, when Tinkham could no longer move and the cold had already won the argument. And the lesson underneath it is the one the mountain keeps writing in different handwriting each time. Light and fast works beautifully, right up to the instant it removes the very margin it was supposed to be, and then it is just light, and alone, and much too far out. There is a part of the 1994 story that has to be handled carefully, and I'm going to handle it the way the record demands, which is to lay out that it is disputed and then decline to pretend I can settle it. Jeremy Haas's conduct that day, the decision to leave Tinkham and go on for help, the decisions that led them onto the ridge in the first place with that forecast in hand, has been read in completely opposite ways. Some accounts have treated Haas as a survivor who did the only rational thing a person could do, who saved his own life because staying would have killed him too without helping his friend, whose crawl to the observatory was an act of endurance. Other accounts, including from people in the rescue community, have condemned the choices harshly, seeing recklessness in the decision to go up into a known killer forecast light and fast, and worse in what followed. Both readings exist in the public record. I am not going to adjudicate between them, because I was not there, and neither were most of the people with the strongest opinions. And this mountain has a way of making the survivors into villains or heroes, depending on who is telling it, when the truth is usually that a human being made a series of decisions inside a collapsing situation, each of which felt forced by the one before. What is not in dispute is the mechanism. The escape route ran into the wind. That is the fact that matters, and it does not need a verdict on anyone's character to do its work. So the forecast did not close the gap. Knowing the future did not help, because knowing a storm is coming is not the same as being able to leave once it arrives, and the mountain's geometry can turn retreat itself into the thing that kills you. What is left? What is the last hope, the last piece of technology that might finally beat this place? The answer, the one that felt like it had to be the answer, arrived with the 21st century. If the problem is that help cannot reach you fast enough, then the solution is to summon help instantly, to carry a device that can reach across the entire distance in seconds, that can tell a rescue coordination center precisely where you are the moment you get into trouble, that removes the delay between the emergency and the alarm, a satellite beacon. Push the button and the world knows immediately, and it knows exactly where you are. Surely that closes the gap. Surely if the signal is instant and the location is exact, the rescuer can come. Kate Matrosova had that device. She pushed the button, and she is the reason we know, with cold finality, that the gap does not close, because the signal was never the problem. The signal was always fast. It is the rescuer who walks. Kate Matrosova was 32 years old, an accomplished and extremely fit woman, a mountaineer with real ambitions, who had climbed serious peaks and was training for bigger ones. On the 15th of February, 2015, she set out to traverse the northern presidential range, the same exposed high ground that had killed Tinkham, in the grip of one of the most severe cold snaps of the winter. She started early and she moved well, summiting Mount Madison and heading across toward Mount Adams, deep into the exposed alpine zone, on a day when the mountain was producing conditions near the limit of what any human being can survive. And this is where the accessibility of the place and the severity of the day collided. She was fit enough and fast enough to get herself far out onto the most exposed, most remote ground on the range, before the full weight of the conditions stopped her, which meant that when she did get into trouble, she was about as far from help as it is possible to be up there, in weather about as bad as it gets. There is something specific about that ground that ties her death to Tinkhams, and it is worth naming, because it is not an accident that the northern presidential range keeps surfacing in these stories. That ridge, running north from Mount Washington over Clay, Jefferson, Adams, and Madison, is the longest sustained stretch of exposed alpine terrain in the East. Once you are committed to it in winter, there is no quick way off. The slopes on either side drop into steep, trackless ravines. The huts strung along it are locked and dark in the cold months, and the only dependable exits are at the far ends, miles apart. It is a place built for a party moving light and fast in good conditions, and a place with almost no forgiveness the moment the conditions turn, because the very thing that makes it magnificent, that unbroken high traverse, with the whole range, falling away on both sides, is exactly the thing that leaves you nowhere to hide when the wind comes up. Tinkham died on Jefferson. Matrosova was turned back below Adams. They were on the same ridge, 21 years apart, beaten by the same absence of an exit. And she was not careless, and not a novice wandering above her ability. She worked in finance in New York and spent the rest of her life on Sirius Mountains. And the traverse she set out to do that morning was ambitious, but not absurd for someone of her experience. She did what a competent person does. She started early to give herself the daylight. She moved efficiently. She got up and over Mount Madison and pressed on toward Adams, reading the mountain and reacting to it as she went. And when she reached the point below the summit of Adams, where the conditions were simply beyond going any farther, she made the correct decision, the one this entire story keeps insisting people should make. She turned back. That is the detail that ought to stop you cold because it demolishes the last comfortable explanation left standing. The idea that these deaths are always about someone stubbornly pushing on when they should have quit. She did not push on. She turned around, exactly the way every cautionary telling of this story says you must, and it did not save her, because by the time forward had become impossible, backward had become impossible too. The same wind that stopped her from reaching the summit now stood between her and the only way down. The retreat she chose ran straight through conditions that were already killing her. And so she did the one thing there was left to do, the thing the 21st century had finally made possible, the thing that was supposed to change the ending. She reached into her pack and she triggered the beacon. Somewhere below the summit of Adams, turned back by the conditions, unable to go forward and facing the same brutal problem of a retreat that led into the teeth of the wind, Kate Matrosova activated her personal locator beacon at around 3:30 in the afternoon. This is the moment the whole modern promise of technology was supposed to pay off. The beacon fired its signal up to the satellites, and the alarm reached the authorities, and a rescue response began. And all of that happened fast, exactly as designed. New Hampshire Fish and Game, which runs search and rescue in the state, and the volunteer rescue teams were notified and began to organize. The system worked. The signal did its job, and then the mountain did its job, which is to make the distance between the signal and the rescuer uncrossable. The first problem was the location itself, and it is a subtle, cruel, technological failure that is worth understanding. A personal locator beacon reports coordinates, but the coordinates that came in from Matrosova's beacon did not all agree. They scattered across an area more than a mile wide. The likely reason is chilling in its simplicity. The device was operating in cold below its rated limit, colder than it was designed and tested to function in, and in that extreme cold its performance degraded. The one thing the beacon existed to provide, an exact location, was corrupted by the very conditions that had put its owner in danger. Stop and appreciate the irony in that, because it is the whole modern illusion compressed into a single object. A personal locator beacon is a small, rugged, genuinely brilliant piece of technology. You register it, you carry it, and if the worst happens, you trigger it. and it fires a coded distress signal with your position up to a network of satellites, which relays it to a rescue coordination center, which alerts the authorities on the ground, all in a matter of minutes, from almost anywhere on Earth. It is the closest thing a person in the wilderness has ever had to a button that summons help out of thin air. But it is an electronic device, and electronic devices have operating limits, temperatures below which their batteries weaken and their circuits misbehave. And those limits are set by testing in conditions the designers judged realistic. The conditions on Mount Washington that night were not realistic by any ordinary standard. They were colder than the device was built to endure, and so the machine sent to defeat the mountain's cold was itself partly defeated by that cold, its position reports scattering into a smear because the very hazard it existed to answer was chewing on the hardware. There is no cleaner illustration of the entire argument than that. Technology reaches into this mountain from the safe modern world, confident and capable, and the mountain reaches back and puts its hand on it, and at the far edge of what the summit can do, the tools built to master the cold begin to fail in that same cold, which left the rescuers with no pinpoint at all, only a smear on the map more than a mile across in the dark, in a 100-mile-an-hour wind, on the most exposed terrain in the Northeast, and one way to close it, on foot, with their bodies. It is worth walking through what a rescue actually is, step by step, because the word makes it sound like a single act, and it is nothing of the kind. A rescue begins with recognition, someone realizing a person is in trouble, which on that afternoon happened almost instantly, because the beacon fired and the alarm reached the authorities within minutes. Then comes authorization and coordination. The agency responsible, in New Hampshire the Fish and Game Department, taking the report, making the decision to launch, and calling out the volunteer teams who do the actual climbing, people who have to leave their homes and their jobs and drive to the mountain in the middle of a savage cold snap. Then preparation, gathering gear, forming teams, choosing routes, because nobody sends human beings into a 100-mile-an-hour wind without a plan for getting them back out. Then travel, the approach, hours of climbing just to reach the bottom edge of the search area before any searching can even begin. Then the search itself, sweeping terrain in the dark and the blowing snow, fighting for every foot. And then, if you find the person, the approach and the transfer, physically reaching them and moving them, which for an injured or unconscious person in that wind can be the hardest and slowest part of the entire operation. Every one of those steps takes time, and every one of them is slowed or stopped outright by the same conditions that put the victim in danger to begin with. The beacon compressed the first step, recognition, down to almost nothing. It did nothing at all to the others. The teams still had to be called, still had to drive, still had to climb, still had to search a mile-wide smear of scattered coordinates in the dark, and the mountain fought them at every step exactly as it had fought every rescuer who came before them. That is why a signal that reached a satellite in seconds became a body recovered the following day. The fast part got faster. The slow part, the part that requires a human being to physically cross hostile ground and lay hands on another human being, stayed exactly as slow as it has always been, because it is bounded by the wind, and the wind does not read the beacon. The Madison Spring hut, the AMC shelter that sits in that high col and might have been a refuge, was closed for the winter, shuttered and locked, as it always is in that season. So there was no warm building in the middle of the search area to work from or to hope she had reached. The first team that went out that night, pushing into the wind and the cold and the dark, searched and could not find her, in part because the scattered coordinates sent them looking in the wrong place, on the wrong side of Madison, and they returned around 3 a.m, having found nothing, driven back the way searchers on this mountain have always been driven back, by conditions that punish every foot of progress. Simply reaching the start of the search had meant a drive to the trailhead in the dead of a brutal night and a climb of thousands of vertical feet before the searching could even begin. So the volunteers were already spent and half frozen by the time they arrived at the ground where she might be, with the hardest part still ahead of them. A National Guard helicopter was brought in, the kind of asset that in gentler country can sweep a search area in minutes and change everything. The blowing snow blinded it. You cannot fly a search in a whiteout at 100 miles an hour. The most powerful rescue tool available was neutralized by the same visibility failure that has been erasing the world on this mountain since before there were helicopters, since Lizzie Bourne could not see a hotel 200 yards away. It was the next day before teams could reach the area where she actually was, and when they did, they were working in winds around 108 miles per hour, barely able to stand, searching ground that would have been difficult to cross empty-handed on a calm day. They found Kate Matrosova near Star Lake, a small alpine tarn in the Col between Adams and Madison, about 150 feet off the trail. Her gloves were still on. Her goggles were still on. She had not stripped them off in the confusion of late-stage hypothermia the way some victims do. She had done things right, kept her protection on, and it had not been enough because the conditions were simply beyond what any clothing could hold back for the hours she was exposed. The cause of death was exposure. 150 feet off the trail, with a satellite beacon that had told the world she was in trouble the moment she was in trouble, on the most technologically supported search this mountain had ever seen, and the outcome was the same as 1855, close to a landmark. Off the path by a distance you could walk in a minute on a summer day, killed by the gap between the instant signal and the rescuer who has to walk. Look at the two of them side by side, because the mountain drew the bookends itself. In 1855, a young woman in the wrong clothes, with no forecast, no radio, no beacon, and no rescue service worth the name, died a couple hundred yards from a lit building she could not see. In 2015, an elite mountaineer in the best cold weather gear ever made, with a satellite beacon in her pack and a state rescue apparatus and a National Guard helicopter mobilized on her behalf, died about 150 feet from a trail, her gloves on, her goggles on, everything done the way it is supposed to be done. 160 years apart, every tool between them reinvented from nothing. And the finishing distance was essentially the same. A short walk on a calm day, an uncrossable gulf on a bad one. That is the sentence the whole mountain has been writing since 1849. And Kate Matrosova's gloves and goggles are the punctuation on it. She did not fail out of ignorance, and she did not fail out of panic. She did not strip her own clothing in a hypothermic delusion the way the failing brain sometimes makes people do. She kept her protection on right to the end, which means she was still fighting, still lucid enough to hold the line. And it still was not enough because the conditions that night were simply beyond what any clothing can hold back. Across the hours a rescuer needs to cross that ground on foot. 150 feet, with everything the modern world could offer stacked on her side, and the mountain still had the last word because the mountain has always owned the one variable no invention has ever touched: the distance a human body must travel through the wind to reach another human body, and how long that takes, and what the cold does in between. That is the answer to the last open loop, the one about whether technology can close the gap between the signal and the rescuer. And the answer is no, not because the technology is bad, but because the technology was never aimed at the real problem. Every device in this story improved the signal. The shout became a flare, became a radio, became a satellite beacon that reaches a coordination center in seconds and reports your position from space. Across 170 years, the speed of the alarm went from the pace of a person running downhill to the speed of light. And across those same 170 years, the speed of the rescuer did not change at all. Because the rescuer is still a human body that has to climb up through the wind, the cold, and the fog to physically reach you. And that body moves at the same pace it moved when the searchers from the Summit House were driven back after 100 feet in 1900. The gap between the signal and the rescue is the whole danger of the mountain, and technology has spent a century and a half making one side of that gap faster, while leaving the other side exactly where it was. That is not a failure of any particular device. It is the shape of the problem. The mountain kills in the space between knowing and reaching, and nothing anyone has invented has been able to shrink that space, because shrinking it would mean sending a human being into the same conditions faster, and the conditions are the limit. Now let me put the whole machine back together, because you have seen every part of it operate, and the parts are not separate stories. They are one system, and the system is the reason the title of this is not an exaggeration. The geography sets the constraints. A mountain-oriented broadside to the prevailing wind, at the end of a fetch that begins near the Rockies, with a summit that squeezes fast, clean air against the ceiling of the weather and accelerates it. That is fixed. That has been true for as long as the range has existed, and it will be true long after all of us are gone. The weather activates the constraints. When a deep low and a blocking high pack a steep pressure gradient across the region, the geography turns that gradient into sustained hurricane force, and the force rises with the square of the speed. So the bad days are not a little worse than the calm ones, they are exponentially worse. The tree line strips away shelter for the top 1,900 feet, leaving the most exposed ground exactly where the wind is worst. The fog and blowing snow erase the world, so that a person can be a short walk from safety and not know it. The cold outruns the body's ability to make heat, and disables the brain that has to decide what to do. And the geometry of rescue means that anyone who comes to help has to enter the same trap, and moves at the speed of a climbing human body, while the emergency moves at the speed of physics. The human motives are what feed people into the machine, and they have barely changed. Lizzie Bourne wanted a sunrise. Curtis and Ormsby wanted to reach a meeting and were too fit to be afraid. The observatory crews wanted the measurement, and went out into the worst of it on purpose every hour to get it. Hare and Batzer wanted a hard climb done fast. Tinkham and Haas wanted a winter traverse and trusted their speed against a forecast that told them the truth. Matrosova wanted the northern peaks in full winter and was strong enough to get herself to the deadliest ground on the range. In every case, the objective was reasonable to the person holding it, right up until the moment survival replaced it. And by the time survival became the only objective, the options that would have served it had already closed. That is the pattern, and it repeats because the reasons people go up have not changed, and the mountain has not changed, and the gap between the signal and the rescuer has not changed. Technology changed capability, and capability over and over did not translate into safety, because each new capability either created new confidence or pulled less prepared people higher, or made the signal faster without making the rescue faster, or, in the coldest irony of all, failed at the exact moment the conditions exceeded what it was built for, the way the beacon's coordinates scattered in a cold below its rating. And the history proves the repetition in a way that no single incident could. It is one thing to say, a place is dangerous. It is another to line up an 1855 tourist, a 1900 pair of champion athletes, a 1934 record that killed no one, a 1982 rescuer buried by an avalanche while searching for two climbers who lost their limbs, a 1994 mountaineer who died on Jefferson while his partner banged on the observatory door, and a 2015 climber found 150 feet off the trail with her satellite beacon still transmitting, and to see that they all died inside the same small radius, for the same reason, across 170 years, and across every revolution in equipment and forecasting and communication that the modern world could throw at the problem. The tools changed completely. the outcome did not. That is not a coincidence. That is a system. And the system is the mountain. And the mountain is exactly as dangerous as the machine it runs, no more and no less. And the machine is running right now today while you are hearing this. And people keep coming, which is the part that unsettles most, because it would be tempting to imagine that a mountain with this record would eventually be left alone. And it never is. The reasons people come have not changed, and they are not going to, because they are good reasons, human reasons. The view is real. The challenge is real. The summit is genuinely one of the most accessible high places in the country, and that accessibility is not a trick or a lie. It is a true and permanent feature of the place. The road still runs. The railway still climbs. The observatory is still staffed around the clock. The trails are still cut and marked. And on most days, the great majority of days, the mountain lets everyone up and everyone back down without a scratch and hands them a memory worth having. That is not the exception to the danger. That is the mechanism of the danger, because a place that killed everyone would empty out and stop killing. This place kills rarely enough and forgivingly enough that the reputation of an easy mountain survives every single death and outlives every single victim. The families in the summer sedans do not know the names Lizzie Bourne or Alan Ormsby or Albert Dow or Kate Matrosova, and they do not need to because the road will carry them up and back down in an afternoon, and the second face will stay hidden this time. The mountain does not need to catch many, too. It only needs to keep being reachable, and to keep being what it truly is on the days it chooses to be that, and to keep drawing up people who have every reason in the world to believe those days belong to somebody else. Here is what running right now looks like. On the 3rd and 4th of February, 2023, another one of those Arctic outbreaks arrived over the summit, the kind the mountain has been assembling out of continental cold and the Venturi throat for as long as there has been a summit. The observatory recorded a temperature of 47 degrees below zero and a wind gust of 127 miles per hour. And when you combine those two numbers into what they actually do to exposed human skin, you get a wind chill of 108 degrees below zero, a figure near the very edge of what has ever been recorded on the surface of the Earth. And on that night, with the mountain producing a cold that could kill an exposed person faster than they could react to it, the observers did what the observers have always done, what Wendell Stevenson did with a club on a roof in 1934. They stepped outside on the hour, because the reading only exists if someone goes out and takes it. The most extreme conditions the instruments could measure, and human beings walked out into them, on schedule, because that is the job. And the data does not fall from the sky. And it never has. And below those observers on that same night at the bottom of the mountain, the gate across the auto road stood closed and locked for the winter, the way it always is when the mountain turns into the thing it truly is. The same road that in July carries a family in a sedan to the summit in about 30 minutes, past the tree line, past the ground where Lizzie Bourne froze, and Ormsby fell, and Matrosova was found, all the way to the heated building at the top, without anyone in the car ever once being in danger or having any idea what they are driving across. That is the mountain. 30 minutes and a sticker in the summer. 108 below and a locked gate in the winter. The same rock, the same road, the same summit, wearing its two faces, and the only thing that decides which face you meet is the day you happen to arrive, and whether you understood, before you started up, that the mountain does not care which one you were expecting. The conditions that killed everyone in this story are up there tonight. The road will open again in the spring, and the cars will come back 30 minutes to the top, because it is easy most of the time.